Welcome to Developer Service YouTube channel. On today's episode, we're going to be building an historical weather storybook with weather information from Open-Meteo and history information from History.muffinlabs. Let's see if I type here a location. Let's zoom Paris. Let's show weather and the events. So this application is going to pull the weather from the Open-Meteo and the historical information from the History.muffinlabs, and you can see current weather. You can see the weather conditions. And we also can see historical events. The historical events are not linked to the time itself. They're just being spread out throughout the page through the different hour cards. We can also see the sunrise and sunset. If I scroll a little bit down, we can see 6:29 a.m. that was sunrise, and later in the day there should also be the sunset. If I scroll down, here we have the sunset at 9:05 p.m. And you can see throughout the cards we have notable birds. And we have, for instance, 1900, 1901, notable dates that occur on this day. And depending on the card, we can also have historical events. For instance, this card has historical events. You can see historical events for 2019 and 2024, and even 305. So let's see how we can build this with Open-Meteo, History.muffinlabs API, and the UI, as we can see, with FastAPI. So as I mentioned, the weather comes from openmeteo.com. They provide a free weather API for non-commercial uses, which does not even require an API key. And if we can see the forecast API, the one that we'll be using, it can receive a series of parameters. You can see temperature, relative humidity. As I mentioned, it is a free API, so you can actually click the API URL and it returns all the information. We will also be using their Geo API so that we can obtain coordinates. If I scroll to the end of the page, you can see their available APIs. There's a geocoding API where we can supply the name of a city and it will return us the latitude and longitude that we need to pass then for the forecast API. As for the history events, we're going to be using the API from history.muffinlabs.com. As you can see, it is a page that someone has created because they needed this kind of information. It's basically a scrape from the Wikipedia, and then it's organized as three different items that you can get from the API. You can get for a particular date. You can have the events, births, and the dates. And if you can see the example of the API for today's date, or for the February date, you can see it returns the date, the URL from Wikipedia for that day, the events, and even links. So this is a very powerful API that returns a lot of history events, and it's going to be able to use for our cards to be shown that information. So let's now take a look at the code. As you can see, I have the project here open. And so it's a very simple FastAPI application. We have our main file, our data models, our utils, and our templates with the base template and with the index template. But of course, we need to start with the requirements as usual. So pretty simple requirements. We have FastAPI, UICon, Jinja2 for the templates, Python multipart so that we can use that in the form. Request to download information from Open-Meteo and from history muffins, and the Python data util to perform some operations, and also the AO HTTP, so that you can also provide some of the synchronous requests. We start with our data models, and the data models contains all the data classes that we will use for the application. So we have a class for the weather data, which contains the time, temperature, and the necessary fields. We have one for the daily weather data, which contains the sunrise and sunset. One for the historical events, in this case from what all the see from the API we're going to be interested in here, the text and the Wikipedia URL. Then we have, of course, for the historical data, to provide a list of all the events of the births and the deaths. So a list of the historical event that we saw before. Then all of that to be shown in the UI. It's compiled in a story card, which contains the weather data, the daily weather data, sunrise and sunset, and the list of events from events, births, and deaths. Next, we have our Utils.py, where we provide some of the methods to be able to build the cards. So we set up first our URLs. Besides the forecast API that I mentioned before, we are also going to be using the archive API. So we use the archive API for any day that's not the current day, and the forecast API for the current day. As I mentioned, we use the geocoding API, so that's also the definition of the URL, and the URL for the history MuffinLabs API. We also create an internal location data class, or a class in this case, that contains the name, type the dictionary actually, It contains the name, latitude, and longitude when we are searching for that information. So the first method that we define is precisely the search location, which will receive a string and return a list of the possible locations. And this prepares first the parameters for the geocoding API. And we are only interested in returning 5. We are passing the language as English and returning JSON. Then we take a synchronous client session. We're of course using the GAPI coding URL. We pass in the parameters and we wait for the response. And if we have the results in the response, then with list comprehension, we do every single one of the results becomes a location data with all the name, latitude, longitude, country, and time zone filled in. So then we have our function that returns the current weather data, and so it retrieves the latitude and longitude that we can obtain from the previous function, and it returns a tuple, which is one of the items is the list of the weather data, and also the daily weather data. So this contains the list all the time, the weather data for the hours, and this contains the sunrise and sunset information. So of course we need to obtain the first current date. We set up all the parameters for the API, the latitude, longitude, what kind of information we are looking to obtain, temperature, precipitation, the wind speed, and also the weather code. And of course we're also interested in the sunrise and sunset, and we want for the start and end date, which is pretty much today. Then of course we using the Open-Meteo URL for the forecast API. We get the data, and similar to as before, we parse that weather data. So for each of the records inside the hourly time, so that for each of the hours, we append one of the weather data classes. And of course, then we parse also the daily weather data, which contains the sunrise and sunset, and that we retrieve from the daily information that comes from the API. So that as the API returns an hourly information with all the different times, and it also returns the daily information, which contains the sunrise and sunset. Next, we have a function that actually is called from the other files and returns the weather data, which is the fetch weather data, again, which is the latitude and longitude, and also the date time. And as before, it returns a list not just of the weather data, but also of the daily weather data. So we also set up the today's date, and the selected date we retrieve from the date that has been selected by the user. And if that date is both of them are the same, and the date is the parameter that we passed there. So if the selected date is today, then we actually return the fetch current weather data, the function that we just saw before. If not, we continue and we prepare the parameters for the historical API, which as you can see very similar to the forecast API. And again, we get from the historical archive, we get the data. Then we parse everything to a weather data class, and we pass also to a daily weather data, and we return that information. Then we have the function that returns the historical event. Receives the datetime, of course, and returns the historical data, as we saw before. So the historical data contains a list of events, births, and deaths. So again, we're preparing the URL with the history base API URL, and we pass in also the date and the month. We aggregate that to the full URL. With the client session, we return again on the response as data. We have an internal function that parses the different events. So we can see that when we are returning the historical data, each of the different events is parsed by that parse events internal function, and that will obviously will receive an event list that comes from the events. So we're passing the different events, either the births or the deaths or the actual historical events. So all of that is constructed into a historical event that contains the year, the text, and the Wikipedia URL that gets the links. So in this case, we're using the first link. For each of the events that are passed, it creates this historical event, and that is then returned from the function. And of course, since we have a lot of events, we need to have a way to distribute them through the different hourly cards, as you saw in the introduction. So we have this distribute events function, which returns a list of the historical events. So as we saw there, it can be a list of events, births, and deaths, and the number of cards that we decide to put in a card. In this case, we are going to be defining that as 3, and returns a list which contains also a list of the historical events. So we have some validations that we do at the beginning. So we avoid repeating the historical events unless there's not unique events to fill into the cards, and if that's the case, then we need to repeat randomly some of the events. So first we start by storing the events by the year to maintain some historical context. Then we calculate how many events we need for each card. In this case, we are using 3 per card. And if we have unique events, then we distribute them without repetition. And that's what this if here is checking for that. So for each of the cards, we're establishing a range, and we're just randomly selecting one of it. In this case, we are selecting one of the events because we're not random. If we have enough events, we are filling in the events for the cards, and we're putting it in the distribute events. And if we don't have unique events, then we need to select the random events to put in the cards because they'll end up being repeated. So again, we're doing the range for the number of cards, and we're randomly giving the choice of the events to the list of events, and that gets added to the distributed events list. So now that we have the events and the weather data, we can create the story card. So the story card receives the weather data, which is the list for the hours, the daily information, and also the historical data that we. So first we establish the number of cards. We distribute the events in the cards by calling the function that we just saw before. And then we create each story card, and each story card is pretty much just a story card instance, contains the weather, the daily data, and the events that have been distributed before for the events, for birds, and the deaths. Then we have our main.py, which is our main FastAPI application. So we're instantiating a FastAPI application, we're instantiating the Gingy2 templates, or giving the location of the templates. We're setting up the basic logging also. And then we have the different routes that are available. We have the root path. In this case, when it's a GET request, it just returns the page with the form ready to be selected. It by default fills in the current date. Then we have the GET request when we are searching the location, so when we're filling in the input for searching the location. So we will start searching if we have more than 2 characters, 3 at least, then we are going to do the search. So the locations will be the search location that we saw in the Utils. And of course, if we don't have location, then we return empty. If we do have locations, and for each of the locations, we're going to be creating the HTML for the drop-down icon because we're using also HTMX. So we're actually returning the HTML that's going to be replaced as we are searching in the UI. So we return the HTML for that with the appropriate clicks when you select the precise location. Then we have our poster routed to the root endpoint, and of course that's going to receive the location and the date. So we're going to be passing the location, and so the location contains the name, the latitude, and the longitude. So we're going to be filtering that in. We're going to be checking the selected data, and if that is not valid, we will return an error. Also, if the location is not valid, we're also going to be returning an error. Then we're checking if the data is in the future. That will also return an error because we cannot search in the future, even though the Forecast API provides that as a functionality. We do not provide this in the application. Then we're going to fetch the weather and the historical data. So that calls the function that we saw to fetch weather data. This can actually return the current weather data or the historical weather data depending on the data that is passed in. We're going to get the historical events from the fetch historical events as I saw before. Using the create story cards function, we're going to be creating the story cards, and then we're going to be preparing all the variables to return to the template as the context. The story cards, of course, the selected data, also the weather data, and if it's the current day or not. So we just chose a slightly different title in the page depending if it's the current day or not. And of course, we return the template to be rendered. And if there's any error, then of course we return the appropriate errors. And we have our main execution. We just import a unicorn and we run as the normal import 8000. And we're looking at the row close. So finally, we have our templates. As I mentioned before, we're using HTMX. So in our base HTML, which contains the base that is then reused by the index HTML. So we're importing HTMX. We're also importing the Bootstrap icons and also Bootstrap 5. That's how we're building our layout. Then we're defining some of the styles that we see in the page, both for the weather cards, for the location dropdown, for the different sun events and sunrise, and for the different icons. We provide all that styling. Then, of course, we have the main body. Contains a navbar that has the historical event storybook, so the title, and contains the main block content that's going to be filled in by the index HTML. And we also include the Bootstrap 5 JavaScript bundle so that we can use that. And finally, we have our index HTML, which actually renders the the main content of the page itself. So I'll be extending the page HTML, and we are redefining the main block content. So we have our form for selecting the data, the date of that we want to search with. We have our form for the location of the weather, and that gets the source location as you saw, and it's triggered every time that there's a key that is pressed. And then we have the onFocus on blur so that we can fill in the information that comes from the endpoint. It will be populated here by the HTMX call. So if we have the location data, then we're just going to be filling that in just below the input, as we saw in the intro. And then of course we have the button to actually perform the search. If there is an error, we're going to show that in a small alert to the user. And if we have an actual weather data, so after we have search, we're going to be filling that in. So we're going to be filling in the information, either the current or the weather timeline for the historical weather data, depending on if we are searching for the current date or for a previous date. Then we have a row, and we're iterating for each of the cards, and we're compiling a card for each of the weather information. So it will have the time on top, the different weather conditions, where we're showing the temperature, the precipitation, the wind speed. So that's all the information that comes from the weather data. If the current hour of that card corresponds to the sunrise hour, then we'll also be showing the sunrise information. And of course, the same thing if that card corresponds to the sunset hour, we'll be showing the sunset information. And if there are events that are associated to the card, then we're going to be filling those in, the historical events inside each of that events. We're going to be filling in, because as you can see, the events, the deaths or the births, and we're filling in the text, the Wikipedia URL, which you can click on, and also the text description. And that we do for the events, for the births, and for the deaths, like I mentioned before. So as a final example, let's see a curious date, which is going to be the 20/07/1969, and we're going to put, for instance, Washington in the United States. And if I show weather events, we can see that what was the temperature for that day in Washington, the precipitation, and the wind speed. But why is this date curious? This date is curious because if I search for it, it was the date of the moon landing. And as you can see, we have that information from the history events. And you can see in the historical events, 1969, the Apollo program, Apollo 11's crew successfully makes the first human landing on the moon. So as you can see, it's also a very fun way to see the historical events that happen in each day, and also cross-check that with the weather conditions. It's a fun and interesting application that shows not just the applications of the Open-Meteo, the API from the History.muffinlabs, but also I can build a very beautiful UI with FastAPI, and you can learn something about history and the weather at the same time. If you want a more detailed explanation, you can go to the developerservice.blog, and there's the article that corresponds to this video on building these weather cards, and you can read in more detail. I will also leave a link in the description for the source code, and also for the article. And you can visit the developerservice.blog for more content about Python, Django, and AI. Like this video if you like this content. Subscribe for more videos about Python, Django, and AI. And until next time, happy coding!